Dear students, let us see the small introduction about electric charge. We know that electric charge is a fundamental property of matter and charge exists in integral multiple of electronic charge. Electrostatics can be defined as the study of electric charges at rest. Electric fields have their sources in electric charges. In this chapter, we are going to study two fundamental laws governing the electric fields, like Coulomb's law and Gauss' law. Both these laws have experimental basis. Coulomb's law is applicable in finding electric field due to any charge distribution. Gauss' law is easier to use when the distribution is symmetrical. Next, let us know about the Coulomb's law. Coulomb's law states that the force between two charges Q1 and Q2 is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. Point charge is a hypothetical charge located at a single point in space. It is an idealized model of a particle having an electric charge. Mathematically, we define F is equal to Q into Q1 Q2 by R square, where K is the proportionality constant. In SI units, Q1 and Q2 are expressed in coulombs and R is in meters. Force F is in newtons and K is equal to 1 by 4 pi epsilon naught, where epsilon naught is called the permittivity of free space. We are assuming the charges are in free space. If the charges are in any other dielectric medium, we will use epsilon is equal to epsilon naught into epsilon r. Instead of epsilon r, it's called the relative permittivity or the dielectric constant of the medium. Therefore, F is equal to 1 by 4 pi epsilon naught into Q1 Q2 by R square. From this figure, we can observe that the position of the vectors of the point charge Q1 and Q2 are given by R1 and R2. Let F12 represent the force on Q1 due to Q2 charge. Then, according to the Coulomb's law, the charges are separated by the distance of R is equal to R minus R2, that is equal to R2 minus R1. We define the unit vectors as A12 is equal to R2 minus R1 by R and A21 is equal to R1 minus R2 by R. For that, F12 can be defined as F12 is equal to Q1 Q2 by 4 pi epsilon naught R square A12. That is equal to Q1 Q2 by 4 pi epsilon naught R square into R2 minus R1 by R2 minus R1 whole cube. Similarly, the force on Q1 due to charge Q2 can be calculated, and if F21 represents this force, then we can write F21 is equal to minus F12. When we have a number of point charges, to determine the force on a particular charge due to all other charges, we apply principle of superposition. If we have n number of charges Q1, Q2 and so on Qn located respectively at the points represented by the position vectors R1, R2, R3 and so on Rn. The force experienced by charge Q located at R is given by F bar is equal to Q by 4 pi epsilon naught, where sigma I is equal to 1 to n Qi into R minus R1 by R minus R1 modulus of whole cube. Thank you.